Hello student, this is mathematics class for class 12 and our today's topic is properties of determinant. This is exercise number 4.2. First of all, we will read some properties of determinant, then we will do some questions on this topic. Again, topic is properties of determinant. There are some properties for determinant. The first property is the value of a determinant. First property is the value of a determinant remains unchanged. The value of a determinant remains unchanged if rows are changed into column and column into rows. Listen again. The value of a determinant remains unchanged if rows are changed into column and columns are changed into row. Let us take an example. Suppose a matrix A is equal to 3, 1, 4 and 5. This is a matrix A. When you will find its determinant A. Determinant A is 3, 1, 4, 5. And you know, for finding value of a 2-order determinant, we will multiply this and subtract this. 3 5s are 15. Minus 4 1s are 4. This is equal to 11. The first property is the value of a determinant remains unchanged if rows are changed into column and columns changed into row. Let us convert first row to first column. Then this will be 3 1. Convert second row into second column. This is 4 5. Now we can find value. Value is 3 5s are 15 minus 4 1s are 4. This means this value and this value same. So first property says the value of a determinant remains unchanged if rows are changed into column and columns are changed into row. Second property is if any two rows or two columns, of a determinant are interchanged. Interchange means this row in place of this row and this row in place of this row. If any two rows or two columns of a determinant are interchanged, then sign of that determinant will change. Means if we know A is a matrix whose determinant equal to 11. Let us convert R1 into R2 and R2 into R1. Interchange R1 and R2. So this will become 4, 5 and 3, 1. I am finding its determinant. So 4 1s are 4 minus 3 5s are 15. It is minus 11. Compare this 11 and minus 11. You can see sign of the determinant is changed. The second property is if we change a row by a row or a column by column, or we can say the value of a determinant will remain unchanged if it's any two rows or two columns are interchanged. By this example, this was first row, this was second row, then value was 11. When this is first row and this is second row, in this case, the value is minus 11. So we can say the third properties of determinant is if any two rows or two columns of a determinant are identical. Listen again. If any two rows or two columns of a determinant are identical, then the value of that determinant will be equal to 0. Let us prove this by an example. This is a matrix 2 3 2 3. You can see first row and second row are same. First row and second row are same. Let us find its determinant. So determinant A is 2, 3, 2, 3. 2, 3 is 6 minus 6, which is equal to 0. So, the property is if any two rows or two columns of a determinant are identical, then value of the determinant will be equal to 0. Either the determinant is of order 2 cross 2 or it is of order 3 cross 2. If any two rows or any two columns are same, then the value of determinant is equal to 0. The property number 4. Fourth property according to our book is if we multiply any row or column of a determinant by any constant, say k. If we multiply any row or column by any constant k, then the value of the determinant is multiplied by that constant, that is k. For example, this is matrix A, say 2, 3 and 4 and 5. Here determinant A is equal to 2, 3, 4, 5, which is equal to 2 5s are 10, minus 4 3s are 12, which is equal to minus 2. Let us multiply first row by any constant. Let us multiply first row by 3. R1 changing to 3R1. We will multiply first row by 3. So, this matrix will become 2 3s are 6, 3 3s are 9, 4 3s are, sorry, this will remain as it is. We are just multiplying first row by 3. This is 2 3s are 6, 3 3s are 9 and 4 and 5 are same. Now if we find value of this determinant, now let us find determinant. 6 5s are 30 minus 9 4s are, this is 36, which is equal to minus 6. You can easily see. You can see this value is minus 2, this value is minus 6. Means your answer is 3 times the original answer. Because the property was if you multiply any row or column by any constant, then the value of the determinant will multiply by that constant. This was your property number 4. The fifth property is if any row or column of a determinant is sum of any two terms. Listen again. If any one row or column of a determinant is sum of two terms, then we can express that determinant as sum of two determinant. Let us prove this by an example. This is a determinant A of order 3 cross 3. You can see 3 rows and 3 columns. And you can see first column. First column is sum of two terms. First column is sum of two terms. So we can write this determinant as sum of two determinants. The two determinants will be A, C, E, second column same, 3, 4, 5 and 7, 8, 9 plus B, D, F, 3, 4, 5 and 7, 8, 9. If you expand this determinant and expand this determinant, then you will find sum. The sum will remain same as the expansion of this determinant. So this determinant can be expressed as sum of two determinant because in first column there were sum of two terms. The property number 6. Property number 6 is very important property. Property number 3 and property number 6 most important properties. Property 6 states that the value of a determinant will remain unchanged. The value of a determinant will remain unchanged if to any row or column we add some multiple of any other row or column. Listen. Suppose this is a matrix A, 2, 3, 5 and this is 8. let us find its determinant. Determinant A is equal to 2 8 16 minus 5 3 15 is equal to 1. The value of determinant of this matrix is equal to 1. If we multiply this row by 2, no doubt result will multiply by 2. But the property is that if you will multiply this by any constant and then add this row to this row, the result will remain same. Let us convert R2 change to R2 plus 2 times R1. If we multiply first row by 2, then add this to second row, the result will remain same. Let us see. First row will remain same and second row is R2 change to R2 plus 2 times R1. So 5 will change to 2 times 2 means 5 plus 2 times of 2 4, 5 plus 4 is 9. 8 plus 2 times of 3 means 8 plus 6 14. Now find its determinant. Determinant is 2 4 ja 28 minus 2 4 ja 2 14 ja 28 minus 9 3 ja 27. This is 1. You can see the result is same. If you multiply a row by a constant then add into any other row, the result will remain same. This was your property number 6. The last and 7th property on determinant is just a simple property. This property is determinant AB is equal to determinant A into determinant B. That is, if you multiply two matrix, then you are taking its determinant. On right hand side, you are taking determinant, then multiply. The result will remain same. It will depends on order of A and B. Now, let us do some question. First question for exercise 4.2. This is first question for exercise 4.2. Question is that you have to prove value of this determinant is equal to 0. But you have to do this without expanding. You have to do this without expanding by using properties of determinant. The 7 properties without using or without expanding this determinant prove that value of this determinant will be equal to 0. We have to use some property. Remember third property. The third property was the value of a determinant is equal to 0 if any two rows or two columns are identical. Let us see. We can see no row or no column are identical. Let us try to do. We can see. Let us find a logic. Actually, this is a question of mental ability. We have to think an idea how the two rows or two columns can become same. Let us see. 37 1 ja 37, 37 3 ja 111 and 37 4 ja 148. Means 37 is common from first column. We can write taking 37 common from first column. So 37 is common here 4 and 37 3s are so 3 and 1. So 4 3 1 23 17 1 0. You can see first column and second column are same, and according to third property, if any two rows or two columns are identical, then the value of determinant is equal to 0. So this is 37 into 0. Your answer is 0 because C1 is same as C2. Next question. This question is same without expanding or by using properties of determinant. Prove that value of this determinant vanish or prove that value of this determinant is equal to 0. Without expanding we have to do this. You can see 2 is common from C1 and ABC, BCA means same ABC and CAB means ABC. You can take 2 common from first column and ABC common from a third column. You can write taking two common from C1, taking ABC common from C3. So 2ABC is common. If 2 is common, then first column is 1 1. Second column as it is. If ABC is common, this is also 1 1 1. You can see first column and third column are same. First column and third column are same. According to third property, if two rows or two columns are same, then value of the determinant is equal to 0. So you can write 2ABC into 0 is equal to 0 because C1 is same as C3. So without expanding, we have proved that the value of this determinant is equal to 0. Next question is, if ABC are in AP, then prove that this determinant or value of this determinant is equal to 0. You know what is the condition for ABC to be in AP? For three numbers to be in AP, B minus A must be equal to C minus B, or you can see 2B equal to C plus A. This is the condition of AP, or you can say given A plus C equal to 2B and we have to prove this equal to 0. Actually, this is also the question of mental ability. We have to think an idea how we can make any two row equal, any two column equal, or any row or any column equal to 0. Let us try. We will find the logic. You can see 4 plus 6 equal 10 and 5 multiplied 2 also equal to 10. 2 plus 4 equal to 6 and 3 multiplied by 2 equal to 6. 5 plus 7 equal to 12 and 6 2 are 12. 7 plus 9 16 and 8 2 are 16. In the similar way, 8 plus 10 18, 9 2 are 18, and A plus C equal to 2B is given. So we can see if we add first and third row, if we add first and third row and then subtract second row from it, then we can see 0, 0 and 0. I am writing. The operation is R1 changed to R1 plus R2 minus 2 times. R1 changed to R1 plus R3 minus 2 times R2. That is, add first and third row, then subtract 2 times of second row. What you will get? 2y plus 4, 4y plus 6 minus 2 times of this is equal to 0, because 2 plus 4, 6 and 3 2 are 6. 4 plus 6, 10 and 5 2 are 10. Similarly, 5 plus 7 minus 2 times this, 0, 0, and 8 plus 10, 18, 9 2 are 18. Here A plus C and twice is minus 2B. The other two rows will remain same. That is 3y plus 5, 6y plus 8, 9y plus B, 4y plus 6, 7y plus 9, 10y plus C. You can see, given A plus C or C plus A equal to 2B. When A plus C or C plus A equal to 2B, means 2B minus 2B equal to 0. So you will get this determinant as 0, 0, 0, and this same 3y plus 5, 6y plus 8, 9y plus B, this is 4y plus 6, 7y plus